Hey girls, welcome back to our lessons for chapter 8. Today is goal 5, using the distributive property to factor polynomials. So we have been talking about the distributive property to multiply polynomials, and we know how it works. We take whatever the factor on the outside is and multiply it by both terms on the inside of the parentheses. But today we're going to be working backwards. So instead of starting with something that looks like this, we're going to be starting with something that looks like this and figuring out what do these two terms have in common. They both have an a in common, so we can turn it into something that looks like before it was distributed. Let's get into how will we do this with more complicated polynomials. So the key idea is that you can use factor trees and the distributive property to factor polynomials. Let's say that we wanted to use the distributive property to factor each of these polynomials. First off, the first step in factoring is always to take out the greatest common factor, or the GCF. To review this problem has two terms, making it a binomial. It's a polynomial because it's a sum, meaning it's addition, of monomials, and it's only one variable. There's no negative exponents and no fraction exponents. I have an exponent of 2 and an exponent of 1. And the highest power is 2, meaning that it's a degree 2 polynomial with a leading coefficient of 27. Let's say we wanted to factor this polynomial. The first thing you're going to do is make a factor tree for the coefficients. So 27 and 18. Hopefully you guys know or remember how to make a factor tree. Once you make your two factor trees, you're going to look, what do these two factor trees have in common? So 27 and 18, I see that they both have a common factor of 3. So I'll pull that down to my GCF. But then I notice they have another common factor of 3, so I'll also pull that down to my GCF. My other two factors are just a 3 and a 2. Those are not matching, so I'm leaving them out of the GCF. You only pull factors that match from the two numbers. Once you figure out what the matching factors are, you multiply them together to figure out the GCF. So 27 and 18, they have a greatest common factor of 9. In other words, 9 is the biggest number that can go into both 27 and 18. Now take a look at the variables. You have y squared and y. Remember, y squared means y times y. So its factors are 2 y's. In y to the first, that's just one factor of y. So what do two factors of y and one factor of y have in common? They have in common one factor of y. So in all, the GCF of these two terms is 9y. So whatever the GCF is, that's what you're going to write in the front. So 9y we write down first. Next, you'll put a parentheses. To figure out what belongs inside the parentheses, you want to keep in mind it's always going to match the same number of terms as what you started with. Since we're starting with 2 terms, I know I should have 2 terms in the parentheses. Now to figure out what belongs in the parentheses, you have to figure out, what do I have to multiply 9y by to get 27y squared? I know that to get 27y squared, I would have to take 9y times 3y. Notice that the number in the front is always going to match the number that was left out of the GCF. Or if there's more than one number left out of the GCF, you would multiply those two together to figure out what was the number in the front. In addition to the 3, you also have to think about the y. To get y squared from y, you would have to multiply y times y to get y squared. Then to get my second term, 18y, I have to take my GCF of 9y and multiply it by 2. Since the GCF already has y in it, I don't have to put a y in this term here. 9y times 2 will give me 18y. So this here is my final answer. It's 9y on the outside as the GCF, and you could always check your answer by multiplying it out. If you distribute 9y to 3y, you get 27y squared. If you distribute 9y to 2, you get your positive 18y. So this makes sense that this is the correct answer. Now take a look at the next one. If you have these three terms, negative 4a squared b, negative 8ab squared, and positive 2ab, you want to look at the numbers first, 4, 8, and 2. What's the greatest common factor of 4, 8, and 2? The biggest number that can go into all three of those terms is a 2. 2 can go into 2, 8, and 4. So 2 is part of our greatest common factor. Now look at the variables. Do they have any variables in common? Yes, they all have at least a to the first and b to the first. So our greatest common factor is 2ab. All three of these terms have a common factor of 2ab. Whatever the common factor is, you write down on the outside. Then you figure out, what do I have to multiply this factor by to get each term? To get negative 4a squared b, you would have to multiply the GCF by negative 2a. To get negative 8ab squared, you would have to multiply the GCF by negative 4b. And to get 2ab, you would have to multiply the GCF just by 1. A lot of people forget to have this third term times 1 here, but you should catch that if you go to check your work and distribute it out. You would notice if there wasn't a 1 here, you wouldn't end up with your third term. So that's how you would know that you did something wrong. And keep in mind that however many terms you start with are how many terms you should have in the parentheses. Now go ahead and try the practice problems that I have for you below. Okay, here are the answers to those practice problems. For the first two terms, they have a common factor of 3. They don't have any variables in common. For problem B, these three terms have u and t in common. For problem C, these two terms have 3k to the 12th in common. For problem D, it was a little harder because it had a fraction on it, but notice that they have the same denominator, so that is part of the common denominator as the GCF, but 7 and 17 do not share any common factors, so that's why the numerator is just a 1. Then for the variables k and k cubed, what do they have in common? A factor of k. And then you can figure out the other two terms by asking yourself, what do I have to multiply the GCF by to get the first term? What do I have to multiply the GCF by to get the second term? Problem E, these two terms have a common factor of 15x to the 5th yz. And for problem F, we have 3 terms, but all they have in common is a 4. Hopefully you got some or all of those practice problems. GCF, factoring the GCF, is just going to be the first step in our factoring problems, and we're going to do a lot more complex factoring problems in our next few lessons. So make sure you get a good grip on factoring the GCF first and ask any questions you might need, because you need to have this down before you move on to the next lessons in Chapter 8. I'll see you guys again for building on this, like I said, in the next lesson. This is just going to be the first step, and then we'll factor out more after that. Bye, guys.